In the silent depths beyond our solar system, an interstellar wanderer entered unannounced. It wasn't a meteor, asteroid, or stray planet. It was 3I Atlas, only the third confirmed object from another star system to grace our sun's neighborhood. As this visitor slingshots past Mars and races inward, telescopes around the world have registered signs that defy our expectations. Water vapor spraying at vast distances and a coma enriched in CO. These are not the hallmarks of your average solar system comet. As it nears its closest approach to the Sun, Perihelion, a high-stakes drama unfolds. Will it erupt, fragment, or emerge changed? Tonight, we embark on the story of 3I Atlas, its discovery, its revelations, and what it might teach us about the galaxy beyond. The discovery and first glimpse on July 1, 2025, the Atlas survey in Chile. The asteroid terrestrial impact last alert system flagged a faint object moving too fast and on a trajectory too odd to belong to our solar system. Within days, orbital calculations confirmed it was hyperbolic, meaning it was not bound to the Sun, but simply crossing through. It would visit and then depart. Scientists soon dug through archival images. They found that this object had appeared faintly in earlier survey data, but gone unnoticed until now. By mid-July, Hubble trained its gaze on the object. In the July 21st image, the comet revealed a teardrop-shaped dust cocoon streaming off an icy nucleus, with the stars in the background streaked from tracking motion. Unusual activity, far from the Sun. Comets from our system typically begin their dramatic outgassing when they cross somewhere between 3 and 2 astronomical units. The warmth on the Sun turning ice into vapor. But 3I Atlas had already surprised astronomers before it even got that close. Water release at 2.9 astronomical units, using instruments like NASA's Neil Gehrels Swift Observatory. Researchers detected hydroxyl O emission lines, a direct signature that water molecules were breaking apart in sunlight. In simpler terms, water is being released into space. The estimated rate approximately equals 40 kilograms of water per second, comparable to a fire hydrant flowing full blast. That's truly remarkable so far from the solar furnace. CO dominance and a volatile inversion even more puzzling. Spectroscopic studies show the comet's coma is CO₂-rich, meaning carbon dioxide may be driving more of the outgassing than water, a reversal of what we normally see in solar system comets. In many comets, water sublimation is the dominant driver as they near the Sun. But in 3I Atlas, the more volatile CO, and possibly CO, seems to lead the show early activation, around 6O. What's even more extraordinary, archival data suggests weaker levels of activity may have begun as early as 6 astronomical units, long before typical comets turn on. That early venting implies that 3I Atlas is fundamentally different in structure or composition. Its internal ices may sit closer to the surface, or fissures may allow internal heating far earlier than expected. Dust properties and polarimetric measurements, how dust scatters polarized light, suggest the dust grains are unusually fine or structurally unique compared to comets in our solar system. In other words, the dust is telling a story of a foreign origin. Together, early water release, CO dominance, and odd dust behavior point to a nucleus that is highly volatile, porous, or fractured. Theories and origins: what could explain such odd behavior? Let's explore leading ideas. Cold formation in a distant protoplanetary disk. The CO dominance suggests 3I Atlas may have formed in the frigid outskirts of its home stellar system, in a zone colder than where most comets in our solar neighborhood formed. There, CO could freeze and be preserved closer to the surface after ejection into interstellar space. It may have remained relatively unaltered, preserving a volatile-rich interior less tampered by solar heating. Porous, cracked sponge structure. Alternatively, the nucleus might be highly porous or fractured. Sunlight, even weak, could penetrate deeper, heating subsurface pockets of volatile ices earlier than usual, building pressure and cracking the surface to vent gases. In effect, the comet behaves like a leaky sponge rather than a solid, icy rock. Layered volatile zones, another possibility. The outermost layers may be depleted of supervolatiles, while deeper zones still have CO or CO. As the surface warms and fractures, those inner volatile layers could be exposed, causing bursts or jets. It's like opening the valve to internal reservoirs. Interstellar chemical fingerprint because 3I ATLAs likely formed around another star. Its elemental and isotopic ratios, carbon, nitrogen, oxygen, organics, may record the conditions of its birthplace. The peculiar dust polarization hints at different grain structure, crystallinity, porosity, coatings from its native environment. Speculation and artificial hypotheses as with previous interstellar objects. Some voices, notably Avi Loeb, raise speculative ideas. Might the comet behave oddly because it's artificial or engineered? While intriguing to some, the bulk of evidence points toward a natural, volatile, rich cometary object. The Perihelion gamble, all the buildup, leads to one moment. Perihelion, the comet's closest approach to the Sun. What might happen? Timeline and distance current orbital calculations place Perihelion around October 29, 2025, at approximately 0.53 astronomical units from the Sun. But there's complication. As it nears perihelion, 3.1 ATLAs will pass behind the Sun from our Earth-based viewpoint, making continuous observation difficult. 3 key scenarios. Dramatic outburst, surge in activity. Solar heating may crack open volatile reservoirs, triggering jets, rapid brightening, and an elongated tail. Fragmentation, structural failure. The nucleus might not withstand thermal or rotational stress and could break apart, exposing internal layers dramatically. Relatively quiet passage if most volatile layers are already outgassed or the structure is sturdier than expected. It might survive with moderate activity. The observational strategy astronomers plan, overlapping observations from Hubble, James Webb, and other space telescopes. Ground observatories. When possible, spacecraft assets. Mars orbiters. Solar probes. Post-perihelion follow-up, comparing pre-post spectra if 3I Atlas survives. It should re-emerge into view around December 2025 to 270 million km away. For one final observational window, the stakes and what it means, what we learn from 3I Atlas could reframe how we study interstellar visitors forever, expanding the sample of interstellar objects. With only Oumuamua and Borisov before it, 3I ATLAS expands our census of interstellar visitors. Each new object reveals greater diversity in composition, behavior, and origin. Probing galactic material exchange, how common is it that star systems exchange cometary debris? Are there many such objects crossing the galaxy now, hidden? 3.1 Atlas helps anchor models of interstellar ejection, survival, and detectability, testing thermal physics and volatile retention, observing how solar heating alters the comet, volatile ratios shifting. Fragmentation, dust morphology helps refine our models of comet thermodynamics, structure, and lifetime. Clues to alien protoplanetary environments because 3I Atlas likely formed beyond. Its composition and grain structure may carry the fingerprint of its birth environment, perhaps revealing chemistries or materials different from our solar neighborhood. Improving observational readiness. Each successful observation, early detection, and real-time monitoring builds our capacity to catch future interstellar visitors. Maybe intercept one with a spacecraft someday. Epilogue and cautionary notes, all numbers, mass loss, volatile ratios. Size estimates are preliminary and subject to adjustment as more data arrives. The perihelion date or distance may change slightly with orbit refinements. Gaps will likely occur in observations during solar conjunction. Unexpected behavior outbursts, jet asymmetries may surprise us. While speculative ideas exist, the consensus currently favors a natural explanation. For now, 3I ATLAs is our messenger from another star system, a cosmic traveler whispering tales of distant worlds. We watch, we wait, we learn.